Hello and welcome to the effect of attention deficit hyperactivity disorder on a developing brain, presented by U3095374. As we know, attention deficit hyperactivity disorder actually has three types to it: the predominantly inattentive type, the predominantly hyperactive type, and finally the combination type. Symptoms of a predominantly inattentive type are they are easily forgetful in daily activities, they are easily distracted, they lose things, they avoid or dislike tasks requiring a lot of thinking, they have difficulty with organisation, they struggle to follow through on instructions, they do not appear to listen, have difficulty sustaining attention, and they fail to give close attention to details or quite often make very careless mistakes. Symptoms of a predominantly hyperactive type. They fidget with hands or feet or like to squirm in chairs. They have difficulty remaining seated. They run about or climb excessively, especially in children. Difficulty engaging in activities quietly. They act as if driven by a motor. They talk excessively. They blurt out answers before questions have even been completed. And they have difficulty waiting or taking turns for different aspects, different things. Now, the history of ADHD is actually quite interesting. When we think of ADHD, we think it's only about 20 years old. But in fact, ADHD is more than 100 years old. It would be in 1902 that Sir George Still was the first person to describe ADHD. It was published in a medical journal. And then when we look at the first treatment of ADHD, it would be reported by Charles Bradley in 1937 by using stimulant medication. In 1968, an early review of ADHD, focusing mainly on hyperactivity, was published in the Diagnostic and Statistical Manual of Disorders, or DSM-2. In 1980, DSM-3 was published with greater focus on lacking attention, in which the term attention deficit disorder was created. In 1987, DSM-3R was the first time that ADHD was recognized with both aspects of lack of attention and hyperactivity. So then we must question, what is happening in the ADHD brain of a developing child? And so we will look at the main areas that ADHD affects in the brain. First is the cerebellum, which is Latin for little brain. It is that red area in the picture. It has more neurons than the rest of the brain put together. It also has an enormous role in movement, balance, coordination, and motor learning. In regards to ADHD, though, it is the function of a timing and attentional shifting that we are most interested in learning about. Then we will look how ADHD affects the brain. So MRI studies have consistently found that the volume of the cerebellum in the ADHD brain is smaller than a normal brain by up to 6%, and this remains consistent throughout adolescence. The area which is most affected by the reduction is the posterior inferior lobe of the cerebellum. This smaller cerebellum volume has been associated with both greater attentional problems and the smaller posterior inferior lobe with global functioning. So here is the posterior lobe, just down the bottom there. And next we will look at the role of the frontal lobe. Now the frontal lobe is critical for us because it holds is responsible for what is called the executive functions of the brain. So Tripp and Wicks have given a definition of the executive functions as neurocognitive processes that maintain an appropriate problem-solving set to attain a later goal. So for the ADHD frontal lobe, it is primarily responsible for appropriate behavioural responses to both external and internal stimuli. So this is what ADHD researchers are most interested at looking at. Now, the executive functions that are most affected by ADHD are response inhibition, vigilance, working memory, planning, and behavioural responses. It also is interesting to note that the frontal lobe is significantly smaller on the right-hand side and in the prefrontal cortex for an ADHD developing brain compared to a normal child's brain. And next we will be looking at the basal ganglia. Now, the basal ganglia has been shown to have an association with movement in that it is responsible for choosing to stop inhibiting an action. It is also associated with self-initiated behaviours or behaviours that are initiated by the person themselves, the child themselves, and not guided by any sort of stimulus. Finally, the basal ganglia is necessary when learning a new behaviour or a new habit, such as learning to ride a bike. Now, both the caudate nucleus and the putamen are entry points to the basal ganglia, and many research studies have shown that both of these areas show abnormalities when associated with the ADHD brain. Even the globus pallidus was shown in one study to be significantly smaller in boys with ADHD. But it is important to note that at the age of 16, the caudate volumes begin to normalise, which may correlate with the reason that ADHD children at this time seem to gain better control over the motoric symptoms of ADHD. And lastly, we'll look at the frontal striatal pathway. Now, this pathway leads the dopamine from the basal ganglia to the prefrontal cortex. Dopamine is the neurotransmitter that is strongly associated with the brain's reinforcement system. So it's the chemical that rewards us for an action or partaking in something. It's the part of the reinforcement system. Now, there is a shortage of dopamine in the pathway that connects both the basal ganglia and the frontal lobe together. This lack results in the lessening of the joining of environmental stimuli with environmental response. The end result is that reinforcement is not as successful in an ADHD brain compared to a normal brain if the frontostriatal pathway is impaired. And it is also important to note that with the dopamine being disrupted in the ADHD brain, this problem may underlie the core symptoms of inattention and impulsivity and a decreased desire to complete tasks. So in conclusion, we have looked at the history of ADHD, the cerebellum, the frontal lobe, the basal ganglia, and the frontostriatal pathway. And I forgot to delete that last bit, please forgive me. Sorry, just waiting for the next, there we go. And here are the references that I have been using to research all of my the knowledge. Thank you for looking.